Chapter 6. In 6.1, we're going to talk about differential equations and slope fields. So first, let's start off with a definition of a differential equation. A differential equation is an equation involving a derivative. That's it. It's that simple. Differential equations are often involved in two variables. We'll start with working in one, and we'll talk about how they interact with their parent function. So in example 1, we're going to determine all functions y that satisfy dy dx is equal to secant squared plus 2x plus 5. So keep in mind that dy dx represents a derivative. So it's like y prime. So here, this is the derivative. It's not the derivative, it's a derivative. And there's a difference between the and a. And we'll talk about that in a minute. This is the derivative of y with respect to x. So remember that it's also important which variable we're taking the derivative in respect to. Because any variable we're not taking the respect to, it's just going to be a constant. So what we're going to try to do here is to get the equation y. So if we're given the derivative and we want to find y, we need to determine the antiderivative. I'm going to show you how to do this in a couple steps. So step 1. We're going to want to separate the variables by multiplying both sides by dx. And I put multiplying in quotation marks as well, because technically you can't multiply by dx because dx means derivative with respect to x. But I'm just going to show you kind of the procedure of how to do it. And then step 2 is going to be to take the antiderivative of both sides. So here we go. Step 1, well, before step 1, you should write down the problem. So we're going to have dy dx is equal to secant squared x plus 2x plus 5. So now we're going to multiply both sides by dx. And this is going to cancel on this side. And you get dy is equal to secant squared x plus 2x plus 5 dx. So step 2 is to take the antiderivative of both sides. So what this looks like is we're integrating both sides without having actual limits. So we're going to integrate both sides like this. And we get y, because the integral of just 1 dy is y, is equal to, and now we're integrating each of these with respect to x. So the integral of secant squared is tangent of x, plus the integral of 2x is going to be 2x squared divided by 2. So the 2's are going to cancel. So I'm going to get x squared. And the integral of 5 is 5x. But here's one added part that we're going to need that we haven't written before. When we take the derivative of a constant, we get 0. So one antiderivative can have many parent functions. So we have to add plus c, where c, it represents any constant. So the c value represents any constant. And if we look here, I gave you a little explanation or an example of why we can do this. So because the derivative of any constant is 0, the antiderivative can have any constant and have the same derivative. So in example, capital F of x equals 2x plus 1, and capital G of x equals 2x plus 2. So we take the derivative of each, we get f of x equals 2, and g of x is equal to 2. Notice the derivatives are the same, even though their antiderivatives are different. So when you get this function, we call this the general solution of the differential equation. We call this a general solution because I can make c equal 5, 6, 7, 8, negative 10, 1/5. It doesn't matter. So now what I want you guys to do on your own is try this example. I want you to give me the general solution to the function that has a derivative of 4x cubed minus cosecant squared. So go ahead right now, pause the video, try it on your own. Alright, let's see what we get. So, step 1, I like to write the problem again just one more time. 4x cubed minus cosecant squared x. Now what we do is we're going to multiply both sides by dx. So you're going to get dy is equal to 4x cubed minus cosecant squared x dx. So we're going to integrate both sides of the equation. So we write an integral sign. And we're going to do it with respect to each variable. So on the left, we're integrating with respect to y. So the integral of 1 with respect to y is going to be y equals the integral of 4x cubed with respect to x is going to be 4x to the 4th divided by 4. The 4's are going to cancel, so I'm left with x to the 4th. And the integral of negative cosecant squared is going to be positive cotangent of x. And then what we have to do is add a plus c for the constant. And we're done. Make sure that you put the plus c. If you do not, it is incorrect.